An Aeolipile, also known as a Heron's engine, is a simple bladeless radial steam turbine which spins when the central water container is heated. Torque is produced by steam jets exiting the turbine, much like a tip jet or rocket engine. In the 1st century AD, Heron of Alexandria described the device, and many sources give him the credit for its invention. The Aeolipile Heron described is considered to be the first recorded steam engine or reaction steam turbine. The name, derived from the Greek word alpha omicron lambda omicron sigma and Latin word pila, translates to the ball of Aeolus, Aeolus being the Greek god of the air and wind. Predating Heron's writings, a device called an Aeolipile was described in the 1st century BC by Vitruvius in his treatise De Architectura. However, it is unclear whether it is the same device or a predecessor, as there is no mention of any rotating parts. Description and physics. The Aeolipile consists of a vessel, usually a simple solid of revolution, such as a sphere or a cylinder, arranged to rotate on its axis, having oppositely bent or curved nozzles projecting from it. When the vessel is pressurized with steam, steam is expelled through the nozzles, which generates thrust due to the rocket principle as a consequence of the second and third of Newton's laws of motion. When the nozzles, pointing in different directions, produce forces along different lines of action perpendicular to the axis of the bearings, the thrusts combine to result in a rotational moment, or torque, causing the vessel to spin about its axis. Aerodynamic drag and frictional forces in the bearings build up quickly with increasing rotational speed and consume the accelerating torque, eventually cancelling it and achieving a steady-state speed. Typically, and as Heron described the device, the water is heated in a simple boiler which forms part of a stand for the rotating vessel. Where this is the case, the boiler is connected to the rotating chamber by a pair of pipes that also serve as the pivots for the chamber. Alternatively, the rotating chamber may itself serve as the boiler, and this arrangement greatly simplifies the pivot-bearing arrangements, as they then do not need to pass steam. This can be seen in the illustration of a classroom model to the right. History. Both Heron and Vitruvius draw on the much earlier work by Ctesibius. Ctesibius or Ctesibios or Tesibia was a Greek inventor and mathematician in Alexandria, Ptolemaic Egypt. He wrote the first treatises on the science of compressed air and its uses in pumps. Vitruvius's description. Vitruvius mentions Aeolipiles by name. Aeolipile are hollow brazen vessels, which have an opening, a mouth of small size, by means of which they can be filled with water, prior to the water being heated over the fire, but little wind is emitted. As soon, however, as the water begins to boil, a violent wind issues forth. Heron's description. Heron takes a more practical approach in that he gives instructions how to make 150. The steam engine. Place a cauldron over a fire. A bowl shall revolve on a pivot. A fire is lighted under a cauldron AB, containing water, and covered at the mouth by the lid CD. With this the bent tube EFG communicates, the extremity of the tube being fitted into a hollow ball HK. Opposite to the extremity G, place a pivot LM resting on the lid CD, and let the ball contain two bent pipes, communicating with it at the opposite extremities of a diameter, and bent in opposite directions, the bends being at right angles and across the lines FG, LM. As the cauldron gets hot, it will be found that the steam, entering the bowl through EFG, passes out through the bent tubes towards the lid, and causes the ball to revolve, as in the case of the dancing figures. U.S. Navy use. In recognition of the Aeolipile's contribution to steam engineering, the U.S. Navy chose a semblance of the Aeolipile for the boiler technician rating badge. Practical usage. It is not known whether the Aeolipile was put to practical use in ancient times. Hero's drawing shows a standalone device, and was presumably intended as a temple wonder, like many of the other devices described in Pneumatica. Vitruvius, on the other hand, mentions use of the Aeolipile for demonstrating the physical properties of the weather. He describes the Aeolipile as a scientific invention to discover a divine truth lurking in the laws of the heavens. After describing the device's construction, he concludes, "Thus, from this slight and very short experiment we may understand and judge the mighty and wonderful laws of the heavens and the nature of winds."